I'll just do a quick screen share. This is my workstation here. And can everybody see the screen?
Yes, we can.
So basically, you know, the first thing is faults. So as I said, I always like to create what are called unassigned faults in here. So basically what that means is I come in here and I'm going to create basically, let's see here, view. Fault picking, horizon picking here. Where did the other one go? Here's my unassigned. So unassigned fault picks. Okay, so in other words, so a tendency might be for, I'll call it beginners, to say, oh, here's a big fault here, right? And you say, this is fault A. And I'm just doing this really quickly here. We're going to not make this pop up. This is Kingdom, by the way, in case any of you are familiar with it. But so you might say, this is fault A. I'm going to follow fault A all the way through. And you create this fault because almost every workstation, the first thing you do is you create a fault name right here. You see, create fault A. Let's go ahead and create fault A. And we give it a color. Almost every workstation, you know, is some variation of that. Okay. But you're going to find yourself, because we've given you these really complex areas, you're going to find yourself just getting too caught up on that. So what I do is I always come in and just very quickly kind of just observe the faults. And actually this is, let me see, that A, or let me turn off A. But anyway, the idea is you map these unassigned faults, and every workstation, you know, has a way to do these unassigned faults. So does that make sense to everybody what I'm talking about? So in other words, you know, you're just coming here, observing, and you're not trying to say this is fault A, this is fault B, etc. Now these days, you know, people talk about, you know, 3D interpretation. That's fine. I actually find that I can work very quickly in 2D vertical displays. It lets me think about one thing at a time. And then I usually blow through these. I'm just doing this super quick here, you know, but basically when you do fault picking, that's it. You just move line to line. You look at your obvious faults in here, and basically you'll come back later. And once you've done this, you'll take time slices or you'll get other views, and then you'll start to see how these patterns are shaping up. Any questions about that?
Do you recombine them after, or do you leave them like that?
Well, every workstation gives you the option. There it is. So that's the picking I've done so far. Every workstation gives you the option to reassign them later on. And that's why I always begin with unassigned. I don't like this color palette. By the way, I'll tell you 80% of seismic interpretation is the art of the correct color palette. I hate to give you all my secrets too soon, but let's see here. I like the one called Segway Instantaneous Frequency Flip. Okay, I don't want that one. I want the next one. There you go. Okay, so there's, you know, there's an example of the fault picks. And so later on, I have the option to reassign those faults to another place, to another name. So in other words, I can later on, if I decide that a certain fault is fault A, so if I later decide this is fault A, every workstation, whether it's DSG or Petrel, they have a way to reassign it in here. So that's what you'll do. So I like to do this unassigned quickly through the entire area. Let's go to a slice. And then I can see where my faults are falling in map view. And then I can decide that, for example, these three are fault A. So then I decide I'm going to allocate this one, and this one to fault A, this one to fault B, etc. And again, the reason I'm kind of showing you this is that most of these real world settings we're going to give you are very complex. And so it's going to be very hard to figure out which fault is which ahead of time. Because what they do is they anastomose, they separate, they join, they separate, they join. And it's just really tough to know which fault is which. Okay. So any questions about the fault picking? Because that is where I almost always begin. And like I say, I do it quickly. As a rule, I pick in the dip direction primarily, and then I'll pick selectively. So I might pick, like, notice here, there's a line spacing, right? Like here, where did it go? I had picked a line spacing like every 10, right? This is the increment that I'm jumping at here. So let's go to 20. So this is the increment I'm jumping through. So what I might do is I might pick a certain increment in the dip direction, and this is dip here. And then in the strike direction, I might go half of that. So, you know, I might go like every 40. So let's pick a strike line here. So the strike lines, of course, the changes, the faults will be more subtle because let's say cross line. Yeah, see, it becomes a lot harder to pick on the cross lines, which is why you want to pick reasonably densely on the in lines so you can start to know where the faults are in the cross line. So once you get in the groove, and you know, a lot of this work, I like to say, it's about getting in the zone, you know, so once you get in the groove, you've picked your spacing increment and you start, you know, pick. I mean, I go through one line every 15 to 30 seconds, maybe, once I'm really in the groove. And so the idea is I very quickly come through, pick the whole thing. So now I've got a structural or a fault framework. So any questions about that? Because that's really a key step for everyone to be familiar with. Are these all familiar topics to you guys, at least to the geophysicists on the team?
Yes.
Okay.
Yes.
So, okay, good. And then the next thing, as you probably know, is you'll pick horizons. Now, in this case, and this is onshore Texas, so for those of you working Matagorda Island, this is a little bit onshore from you, but notice these growth faults you read about in the paper, that's this deep stuff. But then you'll notice here, there's a shallow section here that in this particular basin is relatively flat. So in this case, it's relatively easy. Of course, this is, by the way, this is a very small survey. This is only like a fraction of the size of what you guys are working. But the next thing is you're going to create horizons. And again, almost every workstation, you will create a new horizon name. So test 01, and whatever, typo, but we'll let it go. You give it a color. And then the really key thing, remember we talked about reflection coefficients. So what's going to be really critical for the non-geophysicists here, these blacks and whites, these are very meaningful. The blacks, I've set my palette up where the blacks are the positive numbers or the peaks, the whites are the negative numbers. So once you create your event, you have to tell it, am I picking a peak or a trough or a zero crossing? So it's really important because remember, this ties back to your acoustic impedance, your reflection coefficient, but you have to decide. So let's say I've decided I'm going to pick a peak in here, which means in this case, with the way my palette is, double check here, the numbers are positive on the black. So I'm going to basically be coming in and picking here in the blacks. As a double check, what I sometimes do, because you know a lot of our business is about double checking all the time, I like to overlay my wiggles just to make sure that if I think I'm picking a peak, I really am picking a kick to the right or a positive number. So this is, now I'm going to take off that overlay. So now we've decided basically we're going to pick a peak. And then, and again, this is maybe more useful for the non-geophysicists, but that's okay. You'll learn something. Your geophysicists probably already know this. So next you come, how do you pick? And so the way I usually like to pick in here is with the fill option, if the data is good. So the fill option, see the F, what you do is you define a window and you can see maybe the little green arrow or the green mark up and down. So that's a parameter I set where I tell it where to go look for that peak. So I've picked here and now it's looking. So 1 click, 2 click, 3 clicks, I've already picked this line, right? Double click. So usually what you want to do is you want to be tied. So I pick an in line, say where I think I know what's going on. I then come to a cross line and you will have the little mark. So now I come to my cross line, I pick that. And now I'm back to, let's put my increment at every 20 here. And let's come here. So now you see what I did by first picking a dip line and then the cross line. I now know through that cross line where I've got to be picking on the next dip line. So it means like I can come here very quickly and pick. And here we go. Again, you get in the zone and you're just picking, at least this is the easy stuff. You know, I mean, you pick your easy stuff just like this. That's taking like what, 5 seconds per line I'm interpreting. So far, so good. Now, what you do, because a lot of you have very tough areas, like some of that North Sea data set. Let's zoom out here. Another key thing, by the way, is really critical. I'm always playing with my scales because it's all about how you look at these lines. So I'm looking, I like to use true distance if I can, not traces per inch. Traces per inch is for the processors. I like to use actually a real scale, 1 inch. So this matches, your geologist understands 1 inch equals 1,000 feet or whatever. So it's really important to play with the scales till you're happy with what you're looking at. So now if I'm trying to map down here deep, obviously it's going to be really, really tough. So if I'm going to pick horizon management, create. So if I'm in bad data 01, make that one brown. Okay, I now go, I don't want to do fill picking. Why? And by the way, this is where the people who want to use all these auto trackers, if you let the auto tracker go by itself, it's going to make lots of mistakes and you're going to find it's going to jump around and you're going to spend more time cleaning it up than if you'd actually looked at the data and thought about it. So what I do when I come to tough data areas, I go to manual picking mode. So manual does not follow the peak or trough. It's just literally what it says. I can draw it wherever I want. And I can do anything I want in the manual. So the advantage of the manual is I can come to really bad areas, like say some of that southern North Sea data we were looking at, or things like this. If I want to map, let's say I think my prospect is in here. I map it manually. And I do the same thing. When you pick using a fill method, or it's kind of a mini auto tracking. Let's come back to horizons in here. Let's look at test 01. Test 01. Okay, so this was the horizon I was picking up above that was shallow. So this is not enough picking. What I would do is I would probably double the number in the left-right direction, and then do the other ones in the north-south. But once you've done your picking and you believe your picks, that's when you can then go to using a controlled auto tracker, which means you're going to now use your picking. And because you believe these picks are solid, and like I say, I would do this usually with a bit more densely picked than this, because right now but you then stick to the areas where you trust what's going on. I'm not going to save that polygon name. You decide what your data type is. In this case, we only have one data type, but you may end up with 2 or 3 data types. And then we let it do its thing. So this is what's called auto tracking. So the program is basically looking at your picks. It's doing a whole bunch of calculations of how it can honor your picks while staying in that peak, in this case. and also while honoring that little window. Remember the green up above and below? And so this is basically the procedure you use where the data is good. So we'll let it finish. And this, by the way, this Stratton data set is a very commonly used public domain data set. So as I said, because it's small, I like to use it to kind of show people some of the things you can do. So right now, the algorithm is trying to honor all my picks and is basically interpolating while also staying within the peaks. So again, I expect most of the geophysicists among you have done this many a time. There we go. There's my map. So I can now see where the structurally high areas are and where the lows are. So now, you know, the nice thing is now I can start to take arbitrary lines that go in a true dip sense and go, say, from the high to the low. So now, you know, this is where I start trying to understand the geology. This is where I go back and see, okay, let's take a look. Let's zoom out. And of course, this is the event we were mapping up in here, this red one. And of course, by the time you have finished the picking here, you have also actually, in some cases, some software, most of them do this, it tells you the confidence in the picking. So this is where it shows you, if you look closely, you'll see the lines I first pick have a slightly higher confidence. Well, those have higher 100% confidence. But all of these, they're over 95%. So this is where I usually QC my horizon picking to see whether my tracker has worked. And usually if something's gone wrong, you'll see the confidence drop very quickly. And then I go erase those zones and come again. Also shows you, by the way, the order it picked in. You see, so obviously this algorithm, it starts with my own picks. And then it gradually, well, actually here, the blue, the ones, you see, it came off my picks, it did those. And then later on, it came to these areas. And then at the end of this, here are the amplitudes. So all you bright spot aficionados here, you can see 5,906. That's your highest amplitude. I usually like to set the color bar back to 0 because I want to know how something compares. So what we're saying is, compared to 0, this whole event is a bright spot here, if you want to call it that. It's a pretty strong event. So this is one, again, I wouldn't be jumping to any quick conclusions about, oh yeah, this is hydrocarbons because it's a high amplitude. Actually, this is probably a regional marker that's just very strong. Go back to time. Another thing I often do here is I want to do a quick contouring of my map if there it is. And all these workstations will have this. So let's say test 1, I want to do a contour map in time. And this is where you pick all your parameters. I want to contour it every how much? Every, I don't want to contour it every 0.006. Let's go at least 0.005. And you decide a variety of details, but I usually let it do a quick first pass, and then I tweak from there. There you go. There's a first contour map right here. And then there's probably 50 different parameters I can play with. I'm not going to do that now, but get used to seeing those. Like if this is not smooth enough because maybe your data is jiggling, I'll apply a smooth. Like let's test what a high level smooth looks like. Yeah, you can see that smoothed it out. And I can do a variety of things. So I would recommend that you get very familiar, the geophysicists, with all the options you have here. Because, by the way, ultimately as a geophysicist, your career lives and dies by your maps. And so those maps are controlled by all these kinds of things. You know, of course, what color, what line thickness, how smooth, what's my contour interval, et cetera, which ones you're going to bold. So that is just a quick view. So Mr. Shane, maybe a little bit more than you had asked for, but this is pretty much where I'd be wanting to get things moving forward as early as possible.
Yeah, thank you. I appreciate your overview on that. That's very insightful.
Yeah, and again, if some of you, now, this Stratton, as it's called, data set, here it is, Stratton 3D. This comes with Kingdom. Like when you have Kingdom, this comes with it. So one reason I really like this is that this has a lot of well information. So not only are you looking at being able to look at seismic, but it has a lot of wells. It has time depth functions. Someone's already picked the tops in here. They're logs, they're LAS files. So you can start to turn on the logs and build stratigraphic cross sections or overlay these logs or whatever. Gamma ray, we put in track 1. Apply. There we go. There's gamma ray. Gamma ray almost always green. I don't like red for gamma ray. So there's the gamma ray. There's, again, your good friend, the geologist, has picked some tops in here. And now you're looking at the gamma ray. Of course, there were a whole lot of other logs in there, the ones related to density and velocity. That's what controls your reflection coefficients. No, those are your acoustic impedance ones. Those are the acoustic impedance is what drives these reflections. So you want to make sure that your reflections are where your logs are telling you they should be. And that's related in part to the well tie. But anyway, I do highly recommend the Stratton data set. It's a really nice, small data set, just a great place to learn your first geophysical picking. So like if you're not a geophysicist, but you want to learn what they do, great data set to do it with.